Alright, this is lesson 18 for 8th grade, and today we did a little bit of review on lines and angles. So today was a lot of me kind of describing some of the things we'll be talking about here with some basic geometry. Not a whole lot of math involved with today, mostly naming angles and lines and segments and rays and things like that. So it's a lot of notation, I guess I would say. Alright, so first thing we need to talk about, a line is a straight path that extends without end in both directions. This is how we would show a line. Notice it's got two arrows on either side of it, and the big important thing about lines is they extend forever in both directions. Okay? So, we could have two different names for this. We could call it line AB or line BA, and if we want to show that with symbols, the same with space, AB or BA. Okay, either one of those would work. Alright, now a ray, that's our next thing here. A ray is a part of a line that begins at a point and extends without end in one direction. So the only difference between a line and a ray is a ray has an end point or a line doesn't. A line goes in both directions forever, a ray goes in one direction forever. So this ray, ray AB, extends forever to the right. Here's how we write that. Ray AB. And our last one here, a segment is a part of a line with two endpoints. Okay? So it's a part of a line, it's something we can actually measure. We can't really measure these two because they extend forever in one direction or two directions. And a segment has two endpoints. It has endings, it has stopping points. So here's how we write segment AB or BA. Alright, notice that the ray, we don't switch those letters around, but which is kind of weird because I believe the 7th grade book said that you could do that. I would say to be safe, just start with the letter that's on your end point and extend it to B. I would keep it like this, just to be safe. Alright? Notice too on the segments here, you don't need the little dots at the end, you can just do a little line there. And for lines, make sure you have your arrows. So that's the notation. Line AB, line BA, ray AB, segment AB, segment BA. These are the same thing, these are the same thing. You can write them either way. Alright. All of this stuff that we're talking about as far as geometry goes, it's all happening on a plane, which is a flat surface that extends forever. So think of the most common plane is the coordinate plane. X, Y is our coordinate. Coordinate plane where we have numbers, positive x's, negative x's, positive y's, negative y's. Extends forever in two directions. It's a two-dimensional figure. So planes are two-dimensional. It's when we start putting planes together, like walls, that's when we get some three-dimensional shapes. But we're not really talking about that yet. So a plane, yes, a flat surface, a two-dimensional surface that extends forever. So keep that in mind. It says here, two lines on the same plane either intersect or do not intersect. If the lines do not intersect, then they are parallel and remain the same distance apart. Lines that intersect and form square corners are perpendicular. Alright, so lines can intersect in two ways. Well, let's see here. First of all, parallel lines, they have the same slope. We have not talked about slope yet, but we will be this year. Parallel lines will never touch. They have the same slope, and they will never intersect. So, will not intersect. Okay? So, parallel lines will not intersect. If we have two lines that intersect at a 90-degree angle or a square corner, as they said in the definition, 90-degree angles, we call those perpendicular lines. Now, if they don't intersect this way, they can intersect a bunch of different ways. You could have something like that. We would just call that a normal intersection. Nothing too special, but we can still use it to figure out angles and some other things in the future with geometry and algebra. But obviously if it's not at a 90-degree angle, it's going to be at some other type of angle. So big idea there, on one plane, lines will either intersect or they will not. Alright, and today I showed the students something about skew lines. So this is my attempt to draw skew lines. Well, let's first look at what they are. So we just talked about lines that were in the same plane. That's on one plane on a two-dimensional surface. They'll either intersect or they won't. Well, lines that are in different planes that do not intersect are called skew lines. For example, a wall and the ceiling represent different planes. A line on a wall and a line on the ceiling that do not intersect are called skew lines. I will try to show you two different walls actually. So we'll pretend that we've got walls that intersect. Two walls that intersect, so basically two intersecting planes that extend forever. Obviously mine won't extend forever, but we'll see what we can do here. We'll use our imagination. Alright, so I'm going to go this way. Something like this. We'll erase that. Alright. So it probably doesn't look too special yet. Okay. And then we've got this extending up here. Something kind of like that. Not my best drawing, but we can see kind of the three-dimensional thing. Now we imagine that these lines are extending forever, or these planes are extending forever this way and this way. So if we look at their intersection, this will actually be a line because they're going to extend forever, that right there. But if we imagine two walls intersecting, we could have lines on those walls that would not touch each other if they're on two different planes. Let's say, for instance, we had one on this wall right here. That extended from here to back here. Well, I don't know if the best thing to do there is to, well, let's try it. We've got that, something like that on that wall, and then we're going to look at this wall right here. This one has, let's say we have a line that goes right like this. Alright, so if we look at those two lines, they're not going to intersect because the one on this plane is up here and the one on this plane is down here. So they're going to go above and below each other, okay? So those are called skew lines. Not a huge deal, but we just wanted the students to think spatially about how you could have two lines on different planes that wouldn't touch each other. Actually, most likely they will not. They would have to be on the same height level in order for them to cross. It would have to be at this intersection right here. But yeah, that's skew lines and a little bit of my artistic ability. They got a little kick out of that. Alright, I'm going to check my time here real quick. We're doing alright. Okay, does intersecting lines form angles? An angle is two rays with the same endpoint. And the endpoint is the vertex, and the rays are sides of the angle. So here we've got two intersecting lines, and they take this angle right here, and they show it over here. So we have a side, two rays, and they all start at this vertex. The plural of vertex is vertices. Basically a vertice or a vertex is any time something comes to a point. So like on those polygons that we've been working with a little bit, like a square, or hexagon or anything like that. Anytime it comes to a point, that's a vertex. Alright? Now we have a bunch of different ways that we can name angles. The important ones, let's go over the easy ones first. If we have just an A at your vertex, you can go ahead and call that angle A. Or the symbol would be the angle symbol, angle A. That could be this one. If you have a 2 or any number in here, you can go ahead and just call that angle 2. Notice that there by the vertex though. Everything kind of stems from the vertex with angles. Now, when we have 3 letters, A, B, and C, we have to say angle ABC, or we have to say angle CEA. Now, these are the only 2 names that this angle can have, and the vertex always has to be in the middle. So if you ever have 3 letters for your angle, the vertex always has to be in the middle, which gives you 2 different names for any angle. So A, B, C, or C, D, A. Remember, vertex, middle. So that's some notation for angles there. And obviously, we measure angles in degrees. A full turn is 360, and a quarter turn is 90. Okay, so 360 for the full thing. Quarter turn is 90. These lines are perpendicular, and that would be a square corner right here. That's what they were talking about before. Okay? And these angle measures create different types of angles for us. We can have an acute angle between 0 degrees and 90 degrees, so less than 90 but greater than 0. A right angle is exactly 90 degrees, or a square corner. Obtuse is between 90 degrees and 180 degrees, and a straight angle is 180 degrees. So straight lines are 180 degrees, or basically, if you want to think about it, half of a 360. And the last thing I want to talk about, once again I want to check my time. Okay, got a few minutes left here. It says if 2 angles together form a straight angle, straight would be a straight line. The angles are called linear pairs, and the sum of their measures is 180. Alright, so if I look at this, we have angle Q SR. So angle QSR plus angle RST don't want to forget my angle sign. RST. Alright, can't really see that very well, but if we add those together, we should get 180 degrees. Okay? And the whole reason for that is because we have a straight line here. So these 2 have to add to 180. So if this was 120 degrees, this would have to be 60 degrees. Alright? I'm not saying that's what the angles are. No matter what they are though, they have to add up to 180. Alright? We'll be using that in the future quite a bit. In fact, we've used it on some of our warm-ups already. Alright, that was basically it for today, a basic overview of some geometry things that we'll be using in the future. The homework should be out on the homework link, and we will see you next time.